Translational partition function. You have learned about the translational partition function where you got that if we have studied the factorization of partition function, there is a presence of the four different directions or the way to get the energy that are divided into the different forms. One was the translational, second was the rotational, third was the vibrational, and the fourth one was the electronic contribution. So today we will discuss the translational partition function in detail. Okay, if you talk about the translational partition function where the formula is this, you have learned it already. So if we say that here the GI mean the degenerate energy or the statistical weight factor here is equal to 1. So by putting the 1 in this equation, the equation become in this way. When we talk about the Schrödinger wave equation that talks about if a particle is moving in a rectangular box in the direction ABC, then it will write the equation of translational energy in this way under the aspect of the Schrödinger wave equation, where it's saying that the translational energy is equal to h square over 8m into nx square over a square plus ny square over b square plus nz square over c square. What does the n square, ny square and nz square mean? Here nx, ny and nz are the principal quantum numbers that are determining the possible value for the translational energy, and obviously ABC are the directions, and nx, ny and nz are the principal quantum numbers. So we are going to use this value further to describe or explain the translational partition function. When you will apply the Schrödinger wave equation in respect of the translational energy, then we will write the translational partition function in this way, where qt is equal to sigma. We have already done gi is equal to 1, so we are not going to take the statistical weight factor or non-degenerate energy level, so we have already done with it. So the remaining equation was qt is equal to sigma E minus et over kt. So the Schrödinger wave equation will be applied to only that portion of the equation, where it is saying that qt is equal to sigma E minus n square nx square h square over 8 ma square kt. How it has happened? Actually, we have talked about the three different forms ABC, three different directions with respect to their quantum numbers nx, ny and nz respectively. So their overall value of the translation energy was Et is equal to full this form, and if we take these factors separately, means that if we take h square nx square divided by 8ma square as separate for the one form, and h square ny square divided by 8mb square for the second form, h square nz square divided by 8mc square for the third form. So when we apply this value of the Et, that is the E minus Et, means exponential raised to power translational energy divided by kt. So when we put the value of Et, mean translational energy, so when we take the particles separately, so we have to write this separately. The equation become in this way. The dividend factors are coming in the denominators and the multiplicative factors are coming in the numerator value. So the overall equation shows that this was the factor for the x line, this was for the y, and this was for the z. So qx is coming equal to sigma, that all factors are very similar to each other. So we are saying, and if we want to take only one portion, or if we want to study the only one direction where we are going to place the particle or molecule, means we have been provided the three spaces or three directions in the rectangular phase according to the definition of the Schrödinger wave equation. So if we are taking only one axis in our mind to place one particular particle that is provided, that is x axis, so we will take only this portion of the equation. So we are replacing the qt with the qx. Here we are denoting that the translational partition function is all about the x-axis, so only this portion of the equation is written here. And translation, when we talk about the translational energy level, so all of the energy levels are so close and so nearly placed to each other, so we can say that they are showing an energy level series in a continuous way, so that there is not as much gap that can be differentiated between the one and translational energy level, third, second, fourth, and continue. But it cannot show the gap or difference between them. It's a continuous flow of the translational energy level. So we can replace the summation with the equation. We can replace the summation where we use the summation, sigma is used, so we can replace the sigma with the integration factor that is used for the continuous change in any mathematical term. So when we apply this equation, integration in place of the sigma, the equation appear in this way. So when we apply the integration in place of summation, equation is in this way. And here we are going to say that h square divided by 8 ma square over kt factor is we are taking is equal to small l. So when we put the small l, equation become in this way. And when we take the only this portion of the equation, that is equal to half under root m over l, under root pi over l. So when we first we are taking this part of the equation as equal to l, and then we are taking this, after putting the value of l, the equation becoming this way. And after that we are taking again this portion into the consideration, and we are saying that this equation part is equal to half under root m over l. So then we are putting this form of the equation back into the 4.35 mean in this equation. So the equation become in this way, where half under root 8 ma square kt over a square is taken as the whole square root or the 1 over 2. So we know that the mathematical use where the under root 8 is equal to 2 under root pi. So when qx is equal to, when we are taking we are seeing here in the part, because here a square and a square are in the square form, and there is a under root form. So under root and the square root of a and h will cancel each other, and a and h will come out as a separately integrate particles, integrate derived constants. And what about the remaining part, that is 8? When we derive the 8 according to the mathematical expression, under root 8 is equal to 2 under root pi. So when we are taking the 2 under root 2 in place of 8, so it will be divided by 2, and the remaining portion will be 2 under root 2. So under root 2 mean, you know, under root mean 1 over half. So we are taking that 2 into the 1 over 2 portion, right? Means that when we are putting the 8, then it is big, remaining part is only under root 2, because this 2 is cut by this 2. So the only under root 2 is remaining, so that we are taking into the bracket, that is for the under root square under root. So the remaining factors that are under rooted means are the 2 pi m k t. The all other like a and h are have come out, and 8 is also further described or solved. So the equation becoming this way. This was all about the x-axis. And when we take the same equation, derived equation for the b-axis, for the z-axis, so in place of the b, we will put b, in place of x we will put y, in place of y we will put z, and in place of b we will put c. The equation for the 3 dimensions are obtained by taking only the use or the further application or the derivation of only one part, and the 2 remaining are assumed according to the first one. Okay. Substituting the value, now it's the time to substitute the values of qx, qy, and qz that are obtained. So when we substitute the value in the 4.32 equation, that was qt is equal to qx, qy, qz, means the translational partition function is equal to the x-axis translational function, y-axis translational function, z-axis translational function. Here we are putting these values in the equation. The equation will appear in this way. Here we are not writing the separate equation. You can write in one step the separate equation where qx is equal to 2 pi m k t half into a over h. Qy is equal to 2 pi m k t half over b over h. 2 pi mkt half over c over h is equal to qz. You are noticing that in three part of the equations 2 pi mkt half and h are common in the three parts, so we are taking into the as a common, and we are adding the 1 over 2 in the three form, so it's becoming 3 over 2, and when we add the h and ah, it become h cube, and the remaining portion that was different, we are taking it out, is the a, b and c that were also in the multiplicative form, so these are taken as out. If we say that ABC dimensions are the about related to the volume of the rectangle that is given in the Schrodinger wave equation, so ABC is replaced by the volume, so the overall equation become 2 pi mkt 3 over 2 divided by h square into v. How this has become h square, and before that it was h cube, to take it into the whole 3 over 2, it has become h square.